Hello guys, this is Jalwat Singh with you today, and today we will learn about the exercise 1.3, and this is the chapter number 1, functions and limits, and this is the lecture number 11. So today we will learn about the problems of 1.3. So first of all I will read the problems, later on we will discuss on that. So exercise 1.3, find the limit of each of the following sequences whose general term is given below. An is equal to 2n plus 1. So problem number first, an is equal to 2n plus 1 divided by 1 minus 3n. So this is the general term we have given. So first of all, what we have to do, we just find the limit, but we don't have given the limit actually. So what we have to do, we just we will suppose take this limit. So limit n approaches to infinity, because the limit is not given, that is why we have suppose 2n plus 1 divided by 1 minus 3n. So what we have to do, we just find get the common, and it should be the highest power. So because we should save to ourselves from the 0 in the denominator, that is why we will get the common highest power. So we will get the common n, and 2n plus 1 divided by n, and n 1 divided by n minus 3. So this is will be cancelled out each other. So limit n approaches to infinity, so it will be 2 plus 1 divided by n divided by 1 divided by n minus 3. So apply limit, we will apply the limit. After the applying limit, 2 plus 1 divided by infinity and 1 divided by infinity minus 3. Anything upon infinity is equal to 0. So it will be 2 plus 0 divided by 0 minus 3. It will be 2 by 3 minus. This is the answer. Okay. So what we have to do, we just get the common, and it should be the highest power. Later on we will move further. So that is all about the problem. The second will be n square minus n and an is the general term, and 2n square plus 5n. So we will do same way already we have done. So what we have to do, we just take the limit n approaches to infinity. So we will get the common n square, and it has highest power. So n square 1 minus 1 divided by n plus n square, get the common, and 2 plus 5 divided by n. So these both cancel out to each other. Limit n approaches to infinity. So 1 minus 1 divided by n and 2 plus 5 divided by n. So now we will apply the limit. This will be 0 and this will be 0, because anything divided by infinity will be 0. So answer will be 1 divided by 2. That is answer. So now we will move further. So question number 3 is easy for you. Do yourself, and question number 4 is also easy. You will just get out the common n, and later on you will apply the limit infinity. You will get the answer. I am going to do question number 5. So question number 5. Question number 5, n 3n minus 1. This is the general term. 3n minus 1. Break it over. Break it start. N power 4 minus n divided by n square plus 2 divided multiply by n cube plus 1. So what we have to do, we just multiply the both brackets in the numerator and the denominator. When you will multiply the 3n minus 1 and the n power 4 minus 1, you will get the 3n power 5 minus n power 4 minus 3n square plus. When you multiply the n square plus 2 and n cube plus 1, then you will get the we will write the limit. So limit n approaches to infinity, already understood, and we will get the common n power 5. So n power 5 you will get the common 3 minus 1 divided by n minus 3 divided by n cube plus 1 divided by n power 4. Later on n power 5 we will get the common as same way. So it will be 1 and 2 divided by n power n square plus 1 divided by n cube plus 2 divided by n power 5. So now we will cancel the 5 power 5, and now we will write the limit infinity 3 minus n 1 divided by n minus 3n cube plus 1 divided by n power 4, and divide we will write the 1 plus 2n square plus 1 divided by n cube plus 2 divided by n power 5. So now what we have to do, we just apply the limit, then it will be 0, it will be 0, it will be 0, all become 0, these all become 0, 3 divided by 1, it will be 3 divided by 1, it will be 3. So that is all about the problem number. So in these problems we have given the general term, later on we will apply the limit. Now we have a given sequence. In the sequence what we have to do, we just make the general term, later on we will apply the limit. We have two tasks at a time. So we question number 6, a sign that determine the limit of the sequence. So we have sequence question number 6 1 divided by 1.2 1 2.3 and 1 divided 3.4. This is the sequence. So in that sequence what we have to do, we just find the general term, later on we will move further. So first of all we will write the general term, it will be 1, and now we will make general term of these terms. So how we will make, we just put the n, because when you will put the natural number 1, 2, 3 and 4, so just put on natural number 1, then will be 1, 2, 2, and in the bracket n plus 1. So this is the general term of that sequence. So now what we have to do, now we will do same way already we have done. So limit, so when you will put the natural number 1, then it will become 1, and 1 plus 1, it will be 1 divided by 2. Okay, and later on you will put the 2, the answer will become 2.3. When you put the 3, the answer will become 3.4. So like that. So now limit n approaches to infinity. Okay, 1 divided by n plus 1. So in that we have not the term in the numerator, then what we have to do, we just apply directly limit. Apply limit. When we apply the limit, the answer will be infinity plus 1. The answer will become 1 divided by infinity square plus infinity. Then it will be 0. Anything divided by infinity is equal to 0. So now we have given question number 7. In the question number 7, what we have to do? We just do the same way, but it's a small trick that we will find the general term. Later on we will move further. 1.2 divided by 3.4 and 3.4 divided by 5.6 and 5.6 divided by 7.8 sorry. So that is the sequence. So what we have to do? We just find the general term. Later on we will move further. So general term will be first we will get 135. So 2n minus 1. So it is the 135. So later on we will write the 2n. Okay, 2n, because you will put the 1, the answer will become 2, and when you will put the 2, the answer will become 4. When you put the natural number, 3, then you will get the 6. So like that. So in the denominator 2n plus 1 and 2n plus 2. So in the denominator, when you will get you will get the 3, then you will put the 1 and you will get the 3, and when you will put the 2 or 1 then you will get the 4. So like that. So this is the general term. Now we will multiply these brackets. It will be the and 4n square minus 2n. In the denominator it will be and 4n square plus 2n and plus 4n square plus 2n plus 4n, n is equal to 4n square minus 2n divided by 4n square plus 6n plus 2. So now we will apply the limit. So we have we have find the general term. So limit n approaches to infinity, and 4n square minus 2n divided by 4n square plus 6n plus 2. So what we have to do? We just get the common n square, limit n approaches to infinity. We will get the common n square because it is highest power. 4n minus 2 divided by n. In the denominator, n square will be 4 plus 6 divided by n plus 2 divided by n square. Okay, these both will be cancelled out. Now we will apply the limit. When we apply the limit, we will what we will get? We will get the 4 minus 0 divided by 4 plus 0 plus 0. So we will get 4 divided by 4 is equal to 1. So this is the answer. So this is all about the question number 7. So now question number 8 is the last question. 3 divided by 2 and 2 divided by 3 and 4 divided by 5 divided by 4 and 4 divided by 5. This is the sequence. So in that sequence, what you have to do? Find what we will find. Write down the general term of the sequence and find its limit. Same way we will find before we have done. So first of all we will find the general term. When we find the general term will be 1 plus minus 1 n plus 1 divided by n plus 1. So now you will put the values. N is equal to 1, 2, 3. Then you will get the first term, second term, last term. So what we have to do, we just find this is the general term. Now we will apply the limit. N approach to infinity. So 1 plus minus 1 n plus 1 divided by n plus 1. So we will apply the limit directly. Apply the limit. So it will be 1 plus minus 1 infinity plus 1 divided by infinity plus 1. So in this is the term, we have a one sort of technique. So limit you have already we will study in lecture number 13. N approach to 0, 1 plus x 1 divided by x is equal to e. So in the same way, what we have to do, we just find the minus 1, anything power infinity is equal to e. So in that term, what we have to do, we just find the 1 plus, we will get the minus e and infinity. So 1 plus minus e divided by infinity, anything divided by infinity is equal to 0, 1 minus 0 is equal to, answer will become 1. So this is the limit. So this is the all about the exercise 1.3. So we have done all problems the same way. So thank you very much. In the next lecture we will start the exercise 1.4. Before that we will doing some problems.